Hello everyone, welcome to 1045 Engineering. Today we are starting with another series on coding. We'll be covering Grind 75, a better Blind 75. Many of you must already be aware of Blind 75. It covers all the questions from easy, medium, hard that are used in your interview questions, interview coding rounds, and we are going to take the series on Leetcode in Java language. So first let's take a look what we are going to cover in this entire series. Then we'll come back to today's question and start solving. Okay, so this is Grind 75. I'll put this link in the video description as well. It's by the same author. It's a better Blind 75. What it does is it creates the schedule of all the questions that we need. You can see you can actually make this based on your weeks. You can change number of weeks, how many weeks you want to cover this course in, how many hours per week you want to give it, and this way. And then it will showcase you what all questions you need to cover in first week, second week, third week, and all. So right now if you can see, we have first problem, and one by one when you solve the problems you can mark them checked. Similarly, if we go down all the way down, it's medium, 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 medium. Now hard begins and it ends. So these are total 75 questions, and they will cover all the questions and all the necessary complications in coding that you need for any of your coding interview rounds. So let's start with the first problem today. Let's quickly take a look and we'll start. So our first problem is the two-sum problem, where we are given an array of integer nums and an integer target. Return indices of two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. Let's look at this question from the website directly. Okay, so you can just come to this website, click on your first problem, two-sum. I had already clicked it, so it was open here. Okay, we can close it. Okay, let's go through the question quickly. Given an array of integer, okay, nums, an integer target, return indices of two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. Okay, so from the examples we can understand we are given an array. Okay, 2, 7, 11, 15, target is 9. So we have to return the indices of the elements which summation would equal to 9. That's like in this case they are returning 0 and 1, because if we add 2 plus 7, so 0th index is 2, 1 is at the next index which is 7, 2 plus 7 equals to 9. Similarly, we can say 11, 15 summation would be 36, that is not equal to 9, and similarly we can check one by one, but they mention that it has exactly one solution. So the moment we find a first solution, we will directly return it, and if by the end we have not figured out any solution, we'll return blank integer array. Okay, so now before solving, please take a minute and try to think of an approach that you would need to solve these questions. What I am thinking right now would be the simplest approach. Let's see what is the simplest approach. Okay, I want to achieve the number 9. I'll start from the first 2. I'll add next number 7. So okay, here we are getting the summation directly, but let's check to this one. I start with 3. I add 2. We want to reach the target of 6. Okay, I start with my I with, we can use 2 pointers, I and j. I keep my I from the 0th index, j at the first index. So first I do I plus j, 3 plus 2 equal to 5, not a solution. I do a j plus plus, I move to 4. So 3 plus 4, not a solution again. And now we have reached the end of the array for j, or our second pointer. So now we'll increment our first pointer, we'll say it will come to 2. 2 plus 4, 6, we get a solution. This would be like the simplest approach that we can take, that one by one we add all the elements one by one. It's like the brute force attack, where one by one we cover all the possibilities, and one of them has to be the solution if the solution exists at all. Let's quickly check how we can write this. I'll try and put comments as well, just in case, to make the solution look better and understandable for everyone. Let's create an array int solution. So this will be our solution array that will be returning. Will be new int of size 2. Why size 2? Because of course we have to return only 2 indices. So we have already created an array of size 2. I've already initialized this array. Okay, now what we want to do is, let me comment it, we want to iterate through our array. Okay, so iterate through the array using 2 nested loops. Why the 2 nested loops? So it's same as keeping 2 pointers, I and j. I will be here, j will be here. First j will reach the end. If the solution is not found, we'll move I, and again j move to the end. Let's have a look at it. So let's create a for loop for int I equal to 0, I less than nums dot length. So nums is the array, the given array, in this case this one, but I is not going to go from 0 till the last index, because we need to keep space for j as well. So I has to be I less than nums dot length minus 1, right? I plus plus. So this was simple as of up till here. Okay, let's enter. Now inside this we'll create another loop for a second pointer, that will be j, for int j equal to, now j is going to start, see we want to cover all these values 2 at a time. So if I is here, j is here, then j is here, then j is here, then I is here, j is here. So j will always start from one step ahead of I, right? So j is equal to I plus 1, and now j can go till the end, right? So j is less than nums dot length, length, j plus plus. Okay, now we'll check if the sum of the elements at indices I and j equals the target, right? Because if it equals the target, that would mean that we have found our solution. So let's enter. Simply we'll check if nums of I plus nums of j equal to target. We'll say solution 0. So this is our solution array that we are going to return. Solution 0 will be, so means the first value in the solution would be the first index, that is I. Solution 1 would be j. Okay, so let me just put comments for everyone to understand. If the sum matches the target, store the indices, right? So this is actually index of first element, and this is index of second element in our solution. Okay, once again, and then once the solution is found, we don't need to iterate further, we'll directly return the solution. Cool. Now in case if the solution is not found, we will return the solution here, which will be a blank array. Let's run this code quickly. Email address in this in order to use your account. Okay, I think I'll pause right here and I'll come back to this one. Okay, I'm back. Sorry, my account wasn't verified. I had just created the Leetcode profile. So let's resume. Okay, so we are going to run this, but yeah, before this let me comment this part as well, so that if no solution is available, return empty array. Okay, let's try to run this. Okay, all the test cases have passed. It's working fine. Let's submit. Okay, you can see it shows some stats. Beats 22.15% of users with Java in runtime, and in memory beats 88%. Okay, so runtime wise, it means this code could have been improvised further, right? Now the thing is, the solution that we used right now, we are using the brute force attacks. So what's the time complexity for this one? Right now we are using the current time complexity of O of n square. So 1 O of n for the first loop, and then again 1 O of n for the next loop, because each element is getting iterated twice, so it's at O of n square time complexity. Let's see if we can improve this time complexity further. I'm very sure this solution would have come to mind for most of us, because this was the easiest solution. But now let's try to improve our time complexity. Let's see, before we jump to second solution, let's look at the problem again. Okay, is there a way that we can solve this problem in O of n time complexity? Imagine I want the summation as 9. Okay, you came to 2. You are like, okay, I know there is a number 2. Now you came to 7. At this point in time, can you know that 7 is part of the solution to make the sum 9? You can, if you are aware that 2 had already come. Okay, let's look at it from here. So I want the target as 6, but now in order to solve it in O of n, I am going to iterate it only once. First I am at 3. I know, okay, if for 3 to be a part of a solution to make 6, the array must have one more 3, correct? So rather than looking for 3 plus 3 is equal to 6, I'll look for, in rest of the array, if 6 minus 3, another 3 exists or not. Okay, I'll move forward. I came to 2. Now for 2 to be a part of the solution, 6 minus 2, 4 should have existed before, right? Then I can mark, okay, 2 is part of the solution, 4 plus 2 is equal to 6, and this is the solution. For 3 was the first element, so of course we could not look back, but with 2 we can look back, and yeah, we know that 4 does not exist before 2. Now when we come to 4, we'll say for 4 to be a part of the solution to make the summation 6, a 2 must exist, and we know a 2 exists. So we can do this, but now we somehow would have to store previous value and their indices, correct? Okay, please take some time and think for the solution, because now I'm going to go over and write the solution. Okay, let's start. Let me just remove this piece of code and we will start again. Okay, so the approach I'm planning to take is Hashmap, because what we can do is we can use a Hashmap. We can store the values and we can store their indices, and each time when we come to a number, we'll search in a Hashmap if target minus this number exists in our Hashmap or not. If it sounded complicated, do not worry. Once we go through the code, you'll understand it. Okay, I'll write the comments as well. So let's say let's create a hash map to store the values and their corresponding indices. Why the indices? Because the solution is the indices, right? So let's create a hash map quickly. If some of you are not aware of hash maps, please check on Hashmap. It must be available in one of my other videos as well. I'll put a link to it. Hashmap integer. So we are making a hash map of integer type. Let's call it value to index. Okay, equal to new hash map. Done. So now we have created a hash map. Now what we are going to do is we are going to iterate through this array. Okay, iterate through the okay, it happens once in a while. Okay, we'll iterate through the array. Which array? Nums array. So let's do for int I equal to 0, I is less than nums dot length I plus plus. Simple enough. Now let's find the negative number. Okay, by negative I mean the complement. So if 2 is my first number, my complement would be target minus 2, 7, and then I'll be looking for 7 if 7 exists in my hash map already, right? Because that's the solution. Each time when we come, like for 2, 7 would not exist, but when we come to 7, we'll check for complement, which is target 9 minus this now element 9 minus 7, 2. Does it exist in the hash map? It does, and we'll find a solution. So let's say int complement equal to target minus nums of I. Okay, now right now our target for this use case is 9, nums of I is 2, so complement is 7. Okay, now we will check if the complement value is already available in the hash map, already present in the hash map. Okay, so how do we check this? If value to index, name of our hash map, dot contains key would be complement. Okay, why the key is complement? Because we are keeping number as key and their indices as values. Okay, you'll see that when we do not find one and when we are saving the array. Okay, if it contains, we want to perform some action here, but okay, if it contains the key, if it contains the value. Okay, so complement is 7, so we want to check if in value.index do we have the 7 available. We are at 2 right now, so hashmap does not have anything. But in case it does, but let's assume that it does not have anything, what are we going to do afterwards? Okay, in case it does not have the value, we'll say value to index dot put, okay, nums of I, the element number and their indices. Let me actually comment this so that it's rememberable. I'll comment it here once. Let's okay, so if the element is not found, or if the complement is not found, add the element and its index in the hash map. Okay, but what if the element is found in our hash map? Then that is part of the solution. That is the solution, right? So we'll say return. Now please pay close attention. New int, we directly creating our index. First value would be value to index dot get complement. So that's our first number. So what we are doing, from the value to index or from our hash map, we are getting the value for this complement. Okay, which would be if, so when we are at 7, we will get the complement as 2, because if we are, when we are at 7, nums of I is 7, target minus 7 is equal to 2, complement is 2. Value dot get complement would be, does 2 exist? 2 exists, so we'll get the value would be index of 2, which is 0, and second index here would be I. Make sense? Okay, sorry, by mistake I had put it here. Okay, makes sense, right? So if we are getting the value, we return this value. If found, return the indices of the current element and the complements value, right? And in case if it does not exist in our hash map, we add the number in our hash map with its index. So every time we are adding like 2 and 0 as the value, 7 and 1 as the value, 11, so it would not be coming till 11, but in case 11 and 2 as the value, 15 and 3 as the value, right? But after all this, if we do not find any solution, we'll say if no solution found, return empty array. Okay, so we'll say return new int. Size would not matter, so we can say 0. Okay, so in previous approach we were using the brute force attack directly, and in this approach we are using the hash map, and now we are iterating it only once. So time complexity for the iteration will be O of n, but the time complexity for searching in the hash map would be log n. So overall time complexity would be n log n, which would be faster than log of n square, sorry, O of n square, as was in the previous solution. Let's run it quickly and check. There is some error. Okay, what is the error? Okay, I missed utils. So we are using hashmap and I missed to import it. Import java.util.hashmap. I know few people use asterisk directly, but I prefer to use the one that we are using. Okay, let's see. Okay, there's one more error. Let's quickly resolve this. I think somewhere we have made a small mistake. Cannot find symbol, hashmap, integer value to index, new hashmap. Cannot find symbol, complement spelling is incorrect. Somewhere complement. Oh. Okay, by mistake. Hashmap. Let's run this now. Okay, it's running. Let's submit and check. So we should get an improved time complexity. Okay, now if you see, we are beating 99.38% of the solutions in terms of runtime. I think our memory we have come down a little, but in terms of in our previous solution, it does not show the stats like this. Okay, yeah, in our previous solution, in terms of time complexity, we were beating 22.15% and 88.35% in memory. So I think previous solution was better in terms of memory consumption, and the current solution is better in terms of time complexity or the runtime. Okay, thank you. This is all from today's problem, and similarly like this, we'll be covering the next problem in next session. Please like, share and subscribe. If you have any questions or any doubts, please comment them in the comment section. I'll get back to them as soon as possible. Thank you everyone. That's all from 1045 Engineering.